Okay. So last time we discussed already. Last time discuss natin yung beams reinforced for tension. Okay, and one-way slab. So ngayon we'll continue our discussion with beams reinforced for compression. Okay, so diretso tayo dito, no? Okay, so basically your beam is reinforced only for tension, and in some restriction, we add up reinforcement for compression. Ano? Most cases is yung yung computed nyo na still ratio is greater than maximum still ratio. Paano nangyari ito? That is because of the limitation of the section of the beam. Okay, in the architectural design, it might be that you cannot increase the beam, the size of the beam. So there's a possibility that you can just uh, add with the requirement in terms of reinforcement that would add for the requirement for the compression forces. So ganito ang mangyari, no? So here, if you have to show the internal forces, you have your T1 corresponds to A is 1 Fy, and then this corresponds to something with a compressive force that is generated by the concrete. Okay, so you have here with the compression depth of the compression block, and then you have here, of course, you have here our distance from here is a over 2. This one is a over 2. Yeah. Okay, so this one becomes d minus a over 2. So, okay, and then you will have here t2 is a is 2 or a is 2 or a is prime. Okay, this could be a is 2 or a is prime. Ano yung a is prime na yan? Ito na yan, ano? And this is now this reinforcement is intended for compression. Kaya ito yan. No? So from here, we can have the relationship that A is prime is equal to A is 2. Nilagay lang niya dito 2 ano, para maging consistent sa 2. So actually, that is A is prime. Okay, so the moment here, that will be generated the distance of that compressive force number 2, which is caused by the reinforcement, is D prime. Ano yung D prime na yan? Yun yung concrete cover. No? Concrete cover, or not just the concrete cover, it's the distance from the sa topmost fiber going to the center of this reinforcement. Okay. What else? So, mga given data na makukuha natin dito MU from the shear moment diagram of from the moment generated for a certain software. Tapos of course yung width ng beam, effective depth, FC prime, you have Fy, and then we need to compute the moment to be carried by the moment generated or created by compression bar, or the compression force generated by this reinforcement located in the compression side. Okay? So ito yung M2, dito naman yung M1. Ito yung parang sa reinforced for tension lang. This one is only reinforced for tension. Then you add up this number 2, now reinforced for compression. Kaya ang tawag nito is doubly reinforcement. Okay? Doubly reinforcement. Okay? Pagka wala itong compression, is single reinforcement. Pagka single reinforcement, ibig sabihin nasa tension lang siya. Pagka doble, both tension and compression. So you have to calculate M2, AS, the total reinforcement, which is just AS is just equal to A1, A is 1 I should say, plus A is 2. Okay? So some formula that we have to remember, memorize. You have here the balance still ratio or PB, which is our reference for our maximum value of of still ratio when both the steel in tension and compression will yield. Actually, pagka nagdi-design tayo ng double reinforced beam, we are assuming that the compression will yield simultaneously with the tension reinforcement. So you have here this formula, very familiar, ano? So how do we compute, by the way, itong P prime has something to do with A is prime. So P prime is equal to A is prime over BD. Okay? Then if still compression will not yield, itong gagamitin nating formula. How do you know if still compression will not yield? Ibig sabihin, yung Fs natin, yung actual, is less than Fy. Hindi siya umaabot doon. Or As is less than Ey. Strain, which is equal to Fy over modulus elasticity of steel. Ito is 200 gigapascal. Ano? We can compute this one when we calculate the strain diagram. Ano? Ito yung strain diagram. Yung actual AS mo dito. Okay? Yung actual AS mo dito, dapat ma-compare mo sa EY o strain at Y, which is equal to Fy over ES. Ito is EC or strain of the concrete, which is equal to 0.003. Meron tayo nitong C, and you have this as D minus C. So we can compute this one. But in double reinforcement, malalaman nyo na, especially in the board exam, malalaman nyo na kaagad. Okay? So let's just continue. Here, maximum steel ratio that we have to remember. Okay, 0.75 row balance, and then you have this steel ratio prime. Okay, usually itong ginagamit natin. Not unless if compression bars will not yield, so itong magagamit natin ng maximum. Okay, so one thing that we have to remember, ito pagka yung FC prime is greater than 30 megapascal, then we are going to use this formula. You have here the base, 0.85, isusubtract natin with this 0.05 over 7. And then yung difference or yung excess ng 30 megapascal. In other words, if your FC prime is 40 minus 30 is 10, then multiply by 0.05 over 7, i-deduct natin to sa 0.85. Kasi usually ang ginagamit natin na value ng beta is 0.85. That is if the FC prime is less than 30 megapascal. Okay. Okay, first, let us analyze how we can come up with our equations.
No, we are both extremely lucky to have lived this long. You would drive us into a place where there are no certain danger.
Oh, ano yan? Okay. So we have here, yung halimbawa ito yung beam natin. Okay. So you have here your AS. Andito yung A is prime. So first, we have here this one generated by the tension reinforcement. Andito yung C1. So mas madali lang siya matandaan, Pagka-reinforced for tension muna. And then this one is 0.85 FC prime. And then you have here the width of the beam, which is B. Andito yung, okay, andito yung D. Okay. And then this is the distance or depth ng compression block, which is A. Andito naman yung neutral axis. Okay. The distance from the topmost fiber is C. Okay. That's why we have A is equal to beta times C. So in other words, this one you have as A over 2. And then you have here this one as D minus A over 2. So what is M1? Okay. So M1 is just equal to this moment. It's either C1 or T1. So you can use T1 times D1, D minus A over 2. Okay. For we know that T1 is equal to C1. Okay. T1 could be A is 1 times Fy, while C1 is equal to C1 point, this one 0.85 of C prime times A times B para ma-complete natin yung volume ng compressive block. So this is 0.85 FC prime A times B. So we have for M1. How about for M2? So draw natin M2. So from here, okay, and then here, andito naman yung para sa reinforcement na yan. Okay? So that is why our C2 is here, itong location ng reinforcement. C2. Andito naman yung T2. Okay? And then, so we have this one. We have this distance as D prime. So you have here D minus D prime. Okay? So M2, from here, we can say that M2 is just equal to, it's either T2, we will use T2, multiply by the moment arm, D minus D prime. Okay? Or we can also use C2, D minus D prime. Because we know that T2 is equal to C2. T2 is equal to A is 2, okay, multiply by Fy. C2, sorry, okay. Okay. We have here C2 is equal to, yan. This is already for reinforcement, so we can have A S prime Fy. Kaya alam natin na C2, no. A is prime is equal to A is 2. A is prime is equal to A is 2. So these are the relationship in double reinforcement. That's why we have Mn is equal to M1 plus M2. Or the ultimate moment, multiply lang natin ang reduction factor, multiply sa Mn. Or we can also say M1, M2. Okay? So, ito lang ang relationship sa double reinforced beam na dapat maintindihan natin. If we know already this reinforcement, so madali na yung pag-analyze natin sa problem. Okay? Okay, so let us try this problem. Okay? I'll read the problem. A rectangular beam has a width of 250 millimeter and an effective depth of 400 millimeters. So let us draw. So you have here, okay. So you have here 250. And then you have effective depth. Andito yung reinforcement. From here to here, the effective depth, which is given to be D equals to 400 millimeter. Okay. Now, the beam is reinforced at the top and bottom section with steel covering of 75 millimeter. Okay. So, meron dito, okay, Meron dito. This one is for AS prime. And then this one here is for AS. The cover here is equal to 75 millimeter. Now, it has a simple span. Span is 6 meters. So L is 6 meters. It carries a uniform live load of 36 kilonewton meter. Live load is 36 kilonewton, hindi ampere, no? Per meter. Okay. Kuha na siya. Moment na siya. Kasi from live load. Okay, moment na yan. Check ko lang. Check ko lang. Okay. Hindi. Load pa lang. Load pa lang. Kilonewton per meter. Then dead load is equal to 15 kilonewton per meter. Okay. Now, if C prime is given, 21, and then Fy is 276, compute the ultimate uniform load. So, number one, ito madali lang. Ito kasi yung 2004 na exam ito, pag sabi ko nga, sabihin naman kung anong load combination, ano? So, in this case, we just use yung 2010 na 1.4. 1.4 W dead load plus 1.7 W live load. Okay. So this is equal to 1.4 W dead load is 15, and then 1.7 live load is 36. So we can have WU or ultimate load equals to 82.2. 82.2 kilonewton per meter. Okay, second question. Second question is, which of the following or compute the nominal moment capacity of the beam at balanced condition? So what is the nominal moment of the beam at balanced condition? So we'll just have to compute what would be the distance of the compressive block at balanced conditions. Ibig sabihin, hindi muna tayo mag-consider ng double reinforced beam. Okay? And we can see later, okay, if we need compression, if we need a compression reinforcement, we can see kasi we are going to compute the steel ratio, steel ratio, or we can also compute the moment, the nominal moment. Malalaman man natin sa nominal moment kung malaki siya sa ultimate moment. Okay, so number 2, compute the nominal moment at balanced condition. So in this case, meron tayong formula na CB is equal to 600 D over 600 plus Fy. Plus Fy. So we have here 600. Effective depth natin is 400. 600 times 400. Then you have 600 plus Fy na 276. Then we can have the value of 273.97 millimeter. This is just CB. How about AB? Yung AB, meron naman tayong formula na gano'n na, di ba? We just add B for balanced condition. What's the value of C prime? This is 21 megapascal, so we can use 0.85. And then you have CB 273.97 millimeter. Then we can have AB equals to 232.9. 232.9 millimeters. Now, how are we going to compute now the moment? Okay. Mn. Okay. Mn, Mn is just equal to C D minus A over 2. Alam naman natin na yung C is equal to 0.85 if C prime. We can just use this one. A times B. Pero yung A mo at balance condition. So therefore, we can use here 0.85. Okay. If C prime is 21, nasa taas na problem. 0.85 if C prime. AB, na-calculate na natin. 232. 232.9. This is millimeters. B, it is 250 millimeters. D is equal to 400 minus A or AB over 2. 232.9 over 2. So therefore, we can compute here the nominal moment equals to 294.7 kilonewton meter. Third question, which of the following gives the total steel area? So here, we are going to assess if we need compression reinforcement. Okay? If we need compression reinforcement. So we have to compute. Here, na-compute na natin. Na-compute natin yung WU. Okay? Now, i-compute natin yung MU. Okay? And once we compute MU, we'll check if what is M1 also. Compute din natin yung M1. Okay? Ano yung M1? So, compute muna natin yung ultimate moment. May W na tayo na compute earlier. So, number 3, what would be the total steel area? So, what is AS? Which is could be equal to AS1 plus AS prime or AS2. So, first, we compute MU. May W na tayo kanina. Knowing that this is simply supported beam, formula is 1 over 8 WU L squared. So this is 1 over 8. Ano yung WU na compute natin kanina is 82.2. 82.2 kilonewton meter. L, 6 meters. 6 meters squared. In other words, we have 369.9 kilonewton meter. Now let us see kung anong value ng A1. Okay? Ano pang value ng A1? Going back, ito yung kuha natin? Okay. Yung beam. Okay. Dito yung T1. And then you have here, for your compressive block, na C1. Okay. And then you have, of course, here is your A. Here is 0.85 FC prime. Here is your reinforcement na may distance na D equals to 400. Okay. So, let us consider first this M1. Mayroon nga bang, the question is, if there is a need for doubly reinforced beam. So, this is D minus over 2. How will we know? Paano natin malalaman kung okay, how will we know if we need doubly reinforced beam? Okay. Dapat itong M1, it should be that sa doubly reinforced beam, dapat yung M1, pagka small siya sa MU mo, ibig sabihin, this one is not enough para mag-resist sa MU. Your MU here, yung calculated na MU natin, is 369, okay? 369.9 kilonewton meter. Pagka yung M1 mo, yung internal moment mo is smaller than that, magko-collapse yung structure mo. So, kailangan dagdagan mo siya ng M2. How you do that? You add for additional reinforcement here para masatisfy niya yung need ng 369.9 kilonewton meter. Now we will see, ano ba yung M1? Let's see. You have M1 is equal to, from here, okay? So, lalagyan na lang natin ng, kasi ultimate, lagyan natin ng reduction factor. Ako, wait, mag-charge ko lang. Okay, so M1 from this drawing we can see ano ba yung value ng M1? Phi, our reduction factor, and then you have ang gamitin natin C1 ano? Kasi wala naman tayong A is 1, so C1 ang gamitin natin. C1, and then you have D minus A over 2. Okay, so we will have here 0.9, C1 is 0.85, FC prime, okay, you have A times B, okay, and then you have D minus A over 2. So let's substitute. Substitute natin. We have 0.9, and then you have 0.85. We have FC prime. Ano ba yung FC prime natin again? It's 21. 21. And then we have A. Ano ba yung A? May na-compute tayo dito na AB. Okay, saan ba yung AB natin? May na-compute tayo na AB 232. Ano? So, ma-compute lang natin, we can have the relationship that AB, we can have this relationship, ano? Just like still ratio. Still ratio is 0.75 of row balance. So we can also have this relationship that is it's also the same. Okay. So if you have, okay. So if you have 232.9 para sa AB, we can also have here A. Okay. So we have here A is equal to 0.75 times yung AB natin is 140, 232.9. Okay. So therefore, we can have here A is equal to 174.7. So we can substitute it here. 174.7 millimeter. Okay. A. B is, the width of the beam is 250 millimeter. D is 400. Ayan. Okay. This is 250. D is 400 minus A again is 174.7 divide 2. So we can have a value of our M1 here. M1 is also already ultimate moment kasi may reduction factor na siya na 0.9. No? So the value here for M1 is 219.4. 219.4 kilonewton meter. Now let us check what is MU. Yung MU is 369, so less, ano? 0.9 kilonewton meter. So, the concept is, kung yung internal moment mo na reinforced by, okay, yung internal moment mo na reinforced by tension only, it will only generate 219.4 kilonewton meter. Whereas the applied moment is equal to 369.9 kilonewton meter. Mas malaki yung applied moment doon sa mag-generate na internal moment na could be created or could be resisted by the tension reinforcement alone. So pagka ito lang, hindi ka magdadagdag ng doble compression reinforcement, magko-collapse yung structure. So what are you going to do is to add a reinforcement here. Kaya siya nagdoble reinforced. Okay? Kaya nagdoble reinforced siya. Okay? So we'll add. Okay. So from here, we can add. We'll put here AS. Okay? AS prime. Okay? So this one is here now, ano? Dito na 'yan. Ito na yung C2 and then ito naman yung T2. Okay? So ito yung D minus D prime. Okay? Ano yung D prime from here? This is D prime. Ano? D prime given ba? 75. Yeah, it's given from the problem is 75. Okay. D prime is equal to 75 millimeter. Okay, so we can, anong question pala nito? Again, total steel area AS. So, compute natin AS1, compute natin ang AS2. So, we can compute therefore that, alam naman natin na MU is equal to M1 plus M2. Mayroon na tayong M1, so therefore M2 is just equal to MU, okay, minus M1. Okay, so next page tayo, hindi na natin makikita ito. Okay. So, I've already mentioned earlier that M2, okay, M2 is just equal to MU minus M1. Okay, nakalculate na natin yung MU kanina. MU is 369.9. 369.9. And then we also calculated M1 which is 219.4. Okay, so therefore we can also calculate M2 to be 150.5 kilonewton meter. Kung meron tayo nito, we can calculate also yung AS2. Ano? First, we calculate first AS1. Ano yung AS1? Okay, AS1 para ano, sabay-sabay FY is equal to C1 0.85 FC prime A times B. Okay? So, therefore, we have AS1 is equal to 0.85 FC prime is 21. A is 174.7. Na-calculate na natin kanina. And then you have B, which is equal to 50. Okay? Divide both sides by Fy, which is 276. So therefore, A is 1 is calculated to be 2,825. 25 square millimeter. Now, how about AS2? So we can use M2. Alam naman natin na M2 is equal to reduction factor. Then we can use T2. Okay? Or pwede na siya AS2 times Fy. Okay? Multiply by D minus D prime. So therefore, we can have AS2, the formula to be M2 divide nitong phi Fy and then D minus D prime. M2, na-calculate na natin ayon sa taas. 150.5 kilonewton meter. Gawin nating Newton millimeter times 10 to the power of 6. You have Newton millimeter. Okay. And then phi, which is equal to 0.9. And then you have Fy. Ano yung Fy natin? 276. 276. Okay. Then you have D, which is 400. D prime is 75 given sa problem. So therefore, we can calculate A is to be 1,864 square millimeter. So if we have A is 1, we have, I should say A is 2, may A is 1 tayo. So the total AS or total steel reinforcement is equal to 2,825 for A is 1 plus 8,1064 for A is 2 is equal to 4,689. Okay, 4689 square millimeter. Okay? So, may katanungan? Any question? Okay lang? Okay, let's continue. Okay, next. We have here a reinforced concrete beam. Okay. A reinforced concrete beam has a width of 300 millimeters and an effective depth of 450. The beam is reinforced with 632. Ito given na, no? Given na yung mga reinforcement. Okay. Okay, so let us draw. Okay. The beam is this one is 300 and then effective depth is 450. This is 450 coming from here. So you have 450. Okay, what else? Here, beam is reinforced with 632 bars at the bottom. So ito, anim siya na 32. Dito naman sa taas, meron siyang dalawang 28. Okay. What else? So the distance or D prime is 65. FC prime is 34.5, FY is 345, assuming that the contribution of compression still may not be neglected and the compression still yields. Okay, nag-yield siya. Which of the following? The same with the tension reinforcement. Pag nag-yield ang compression, it is expected that the tension still also yield. Which of the following or compute the balanced steel ratio? It is considered a singly, consider siya na singly reinforced beam lang. So what is the balanced steel ratio? Oh, so ito lang, ano? Dali lang ito. Formula lang na dapat yung tandaan. 0.85 FC prime. What else? Beta 600. And then you have Fy multiply by 600. Okay. Plus Fy. Now the question is, what is beta? Kasi nga, yung FC prime is 34.5. Yung beta, okay, because FC prime is greater than 30 megapascal. So in this case, we can calculate that beta is equal to, ano yung kung natin kayo na, 0.85 minus 0.05, yung formula natin, over 7 times 34.5 o yung excess ng 30. So you can have, yung mga calculator, hindi ko po na-calculate. Calculate nyo kung tama. Calculate nyo nga. 0.05 divide 7 times. So it's 0.818. Huh?
0.82.
Oh, 82 or 0.818. 818 na lang muna natin. 818. Okay? So let us substitute from here. Anyway, kunting kwan lang naman yung 0.81 or 0.82. Ano? B. Still ratio at balance condition. Let us substitute 0.85. FC prime is 34.5. You have beta na na-compute natin 0.81, 818 or 0.82. Then you have 600. And then you have Fy na 345 over 600 plus 345. Calculate nga ng value. 0.85 times 34.5.
0.044.
Okay, 0.044. Okay. Bilis ah. Maganda yata yung calculator. Okay. Number two. Number two is to compute the balance steel ratio if it is doubly reinforced considering the effect compression of steel. So, ang gagamitin lang natin yung formula ng considering compression reinforcement. Okay. So, number two, you have the following gives the compute the balance steel ratio. So, ito, calculate natin. Balance pagka lagay natin balance pero B plus balance using considering compression steel. Okay. So this is equal to 0.85 FC prime, formula nasa taas, beta 600 over Fy 600 plus Fy. Okay. Plus A is prime over BWD or BD. Kasi minsan, BW or BD, okay? Or width of the beam. W stands for width. Okay? So you will have here ito, na-compute natin sa taas yata, 0.044 yata ito, no? 0.044. And then you have, ano yung area? A is prime, ito, no? Sa taas. The total area is dalawang pi over 4. The diameter is 28 squared. Okay. Then you have BW is 300 times effective depth na 450. So we can have here 0.053. Now number 3, compute for the ultimate moment capacity. Ito na yung magko-compute kayo ng M1 at saka magko-compute kayo ng M2. So here, okay, dapat ma-calculate natin yung okay. Ito yan, ano? So first is para sa concrete, ito, no? C1 at saka T1. Pangalawa naman is para sa compression reinforcement. Nasa taas lang siya konti. C2 at saka T2. May mga A is 1 na tayo at saka A is 2 kasi given yung, ito given yung reinforcement. So may hint na tayo ito. You have 632, A is ito. At saka ito naman, 228, ang A is prime. So, the question is to compute for the ultimate moment capacity. Pwede na tayo diretso sa formula, no? Para may guide tayo. Mu is equal to, pwede Mn muna. Mn kasi pwede ilagay natin Mu is equal to Vmn. Okay? Para saka na yung reduction factor na pag-multiply natin. Okay, so I have M1 plus M2. Ito yung M1 at saka ito naman yung M2. So anong given dito sa M1? A is 1, ano? A is 1, Fy. So A is 1 na tayo. Okay. So we have M1 is equal to T1 or AS1 Fy. And then you have, this one is D minus A over 2. D minus A over 2. Plus M2 na AS prime or AS2 Fy times. Ito naman is D minus D prime. Okay, let's calculate. Ano yung A is 1? Okay? At saka ano yung A is 2? Okay, the total AS, kitang-kita naman sa baba. Ito. Kita naman, no? AS. So you have 6 pieces ng 32. 32 squared. So this is value. A is 6, 32 squared, 4825. Okay? And then you have A is prime, dalawang 28. Pi over 4, 28 squared. So this is equal to 1232 square millimeter. So what is A is 1? A is 1 is just equal to A is minus A is prime. So this is 4825 minus 1232. So meaning you have A is 1, meaning A is 1, 4825 minus 1232, 3593. 3593 square millimeter. So therefore, we can calculate now here. Substitute. You have 3593 for A is 1. Fy is 345. D is, calculate na ba natin ang D? Oh, ang D is given, 450 millimeter. Yeah. Minus, ang A, na-calculate na natin? Di pa, no? It should have, calculate muna natin dito sa C1 is equal to T1. So from here, makakalculate natin yung A, This is, ito yung A. So from this relationship, we can calculate A. Kasi you have C1 is equal to T1. From that, you have, itong taas dito is 0.85. Alam naman natin yan, I'll just write. You have 0.85 FC prime A times B. And then you have A is 1 times Fy. So you have 0.85 FC prime is 34.5. Ito yung tinatanong na A. B is already is given to be tama 300. And then you have A is 1 equals to 3593. And then Fy is 345. So we can calculate A equals to 140.9. Kindly check kung tama. Okay, so we can have here, we'll go back to this equation, 140.9 divided by 2. Okay, then you have A is 2. A is 2 or A is prime. Okay, take note, A is 2 is also equal to A is prime. So you have A is prime is 1232, 1232, Fy is 345, D is equal to 450, minus D prime, ano yung D prime natin? 65, given sa problem. Okay, D prime from here, going here is 65, D prime. So therefore, we can calculate here Mn. Mn is equal to 634 times 10 to the power of 6 Newton millimeter. Or, yung mu na that we are trying to calculate is equal to phi mn. Or is equal, you have equal 0.9 times 6 634, gawin na natin kilonewton meter. Okay? So you have mu, mn ito, mn. Mu equals to 570, 570.6. Madali lang naman siya, yun lang, medyo procedural, medyo mahaba. Okay? Okay lang? Any question? Okay.
Okay lang
So,
po.
I consider that as no question. So, I want you to try this one. Nasa kwan ito ano? Nasa andun sa classroom natin. Try niyo sagutan, please. Saman. Okay. Ano? Ito, ano? Naka-pause na siya. Ito. Pakisagot na lang nito. Okay? I'll give you 10 minutes. And then, after that one, check ko. After 10 minutes na pag-solve niyo, dinner tayo ng 5 to 10 minutes. Baka di pa kayo nag-snack. O kawan, mga 5 to 10 minutes lang. Okay? Then, we'll continue. Okay? So, 10 minutes for answering this one, and then another 5 for break. Okay? 5 to 10 minutes. Okay? A total of 20 minutes para makapagtuloy tayo. Okay? Mga 15 minutes, okay na siguro. Hindi masyado mahaba to. Okay, so let's continue. You have here a reinforced concrete beam has a width of 300 millimeter and an effective depth of 450 millimeter. The beam is reinforced with 632 millimeter at the bottom, and then you have 228 bars at the top. Parang how similar siya sa previous example natin na. Okay, the maximum the FC prime is 34.5, Fy is 45. Pares ba sa
Pares yata, sir.
Hindi naman masyado. Iba. Okay. Iba. Okay. So, may similarity lang, halos parehas, pero let's see. So, the balance steel ratio, yung PB, or row balance. So, we have here, number 1. Formula lang naman siya, no? Is equal to 0.85 FC beta, FC prime, 600 over Fy 600 plus Fy. And then you have A is prime, BD. Okay? So, again, beta has to be computed kasi nga greater than 30 megapascal, okay, yung FC prime. So, you have 34.5 minus 30. So, this is equal to 0.818. Pares lang yung section yata, no? Given 2001, and then we're also given in 2007. Okay? So, A is prime, we can calculate. Dito naman, A is prime is 228 pi over 4, 28 squared. So, that is equal to 1232. 1232 square millimeter. So, you can have there 0.85, 0.818, and then you have FC prime is 34.5. You have 600. Then you have Fy is 345. 600 plus 345. Then you have A is prime na calculated natin earlier, 1232. And then you have B is 300 and then 450. So this is equal to 0.053. Next is yung previous question, row balance sa balance condition at saka iba yung mga question lang, okay? Pero ang problem, almost the same. The same, ano? Ang question lang nagkaiba. So number 2, we should calculate the compression block. So in other words, depth of the compression block. In other words, we just have to use the C1. Okay, so you have C1 should be equal to T1. And this you have 0.85 FC prime. Kahit hindi mo siya i-drawing, alam mo ng formula na ganito. Okay? A is 1. Fy. Okay? But we have to calculate first what is AS para makalculate natin ang A is 1. So AS, andito naman, no? 6 pi over 432 squared, which is equal to A is 4825. 4825 square millimeter. So in other words, you have AS1 is equal to AS minus AS prime is equal to 4825 minus 1232. So you have AS1 is equal to 3593. Now we can use it here. 0.85 FC prime is equal to 345. 345. We are calculating A. B is given to be 300. A is 1 is 3593. And then you have Fy is equal to 345. So we can compute now. So therefore A is calculated to be 140.9. Now number 3. The question for number 3 is just to calculate which of the following gives the nominal moment. Yung unang question, MU. Ito naman, nominal moment. So parehas lang. Hindi lang tayo mag-calculate ng mag-multiply ng reduction factor. So you have M1 plus M2. Okay? Here we use A is 1. A is 1, Fy, D minus A over 2 plus AS prime or A is 2, Fy, and then you have D minus D prime. Okay? So you have A is 1, 3593, Fy is 345, D is 450 minus A na 140.9 over 2 plus A is prime na 1232. Fy is 345. D is 450 minus D prime na 65. So in other words, we have here Mn or nominal moment equals to 634 times 10 to the power of 6 Newton millimeter or 634 kilonewton meter. Okay, so I think this is enough for a doubly reinforced beam, unless you have some questions.
Wala po akong question, sir.
Okay, so we'll continue. Okay, so T-beams tayo. So T-beams, may similarity ito sa discussion ng ng doubly reinforced beam. Kasi meron tayong ina-isolate din natin yung analysis natin ng internal forces. Kasi it falls on the compressive block falls on the web, just like this one. It will be difficult, pag-compute ng total na compression, force na C because of this irregularity ng area. So, mas maganda, isi-separate nyo. Okay? Kasi ang magiging volume nyo yan pag gano'n, no? Kung hindi nyo i-separate, sa taas, itong sa slab nito, sa bandang slab, tapos meron pa dito pag gano'n. O saan ang C? Ganon. Medyo mahirapan. So, the best way is to isolate. Okay? Isolate natin. Isolate itong side ng rectangle dito. Itong malaki na sa may web. Tapos dito sa may slab. I'll show you later. Okay, but first, there are some calculation or checking the B. For example, this for T-beams, according to the SCI code, what will be your width of the flange that we are going to consider? So we have to follow with this condition, okay? Asan yung smallest value ng B? Smallest value of B is the one that we are going to use for the flange, the width of the flange. Okay, so for this case, we're going to choose 1/4 of the span. Kung ano ba, the span is 6 meters. Okay, for example, if the span is 6 meters, ibig sabihin, if you have this beam, itong support, possibly center to center. Okay. So span here, let us say, span is 6 meters. So this is just 1/4. To select B or the width of the flange, this is just 1/4 of your 6 meters. Okay, that's 1.5 meter. The other one is 16T. T is the thickness of the slab. For example, the slab is 100. Say 100, As B prime, halimbawa, B prime mo dito is 300. So let's see what is the value. 16 times 100 is 1,600 plus 300 becomes 1,900 or 1.9 meter. Then other one, okay, Sir Chris. Okay, another one is center to center spacing. Ibig sabihin, spacing between beams. Okay? Anong spacing ng beams? Ito halimbawa, sa spacing, usually halimbawa, spacing natin is mga 4 meters din halimbawa. Or maybe 3 meters. So this is 4 meters or let's say 4,000 millimeter or 4 meters. Among these three, we choose the smallest value of B. Obviously, ito yung smallest value. So we consider the width of the flange equals to 1,500 millimeter. This is our consideration in analysis for the T-beams. Now, there are some cases, there are some cases na along the perimeter or along the edge of the building, so hindi siya T-beam, Kuwan siya, inverted L. Inverted L siya. So this will be our consideration. Okay? This will be our consideration. Okay? Wait. Okay, let's continue. Okay, so let us analyze how we can compute let's say, there's still a reinforcement, what is the compression block, depth of the compression block. So as well know, ganito yung, as I was saying, we're going to separate. Okay. Separate ko yung ito, I'm going to separate this one and then this one. So for C1, we'll just consider this area. Ito yung along with the thickness of the slab. So kung halimbawa, your BW, for example, your BW is 300, and then your B is, let's say, 1,500. So 1,500 minus 300 is 1,200. Hatiin mo to sa dalawa. So this one will become 600. Ano? The other one here is also 600. And to check, you have 600 plus 600 is 1,200 plus 300 is 1,500. Dito ko na lang ilagay. Okay? So this is 600, 600. Okay? So in other words, the volume of this one, C1, the volume of C1 is just equal to 0.85 C prime. Okay? Yung A mo, hindi A, ano? T ang gagamitin mo. T times B minus BW, ito, at saka ito. It is just times 2 of B minus BW over 2. In other words, that is B minus BW. That is for C1. Okay? And then you have for C2, ang consider natin, ito na, number 2. What is the area of this one? The area of this one is just BW multiplied by A. Multiply mo ng 0.85 FC prime, that becomes your C2. Okay? That would be your C2. So in other words, your C2 becomes 0.85 FC prime, okay, multiply by A, and then multiply by BW. Once you have this one, we can also have this relationship C1 is equal to T1. Okay? Gaya din sa double reinforced beam. You also have C2 is equal to T2. Ano yung T1 is equal to A is 1 Fy. Okay? Ano yung T2? Of course, A is 2 Fy. So we can have the total reinforcement A is equivalent to A is 1 plus A is 2. Okay? So now we get the moment Mu is just equal to Mn, or Mn is just equal to first M1 plus M2. Ito yung M1 dito. Okay? This one would be your M1. Ito naman would be your M2. Okay? So now we will see that M1 is either we use C1 or C2. Okay? Pwedeng T1 or C1 times D minus C1, anong distance? Ayan, malinaw naman. No? D minus T over 2 kasi T ang pinaghati dito. T over 2. Okay? And for M2, you have C2 is equal to D minus, this time, A ang hinati. You have A over 2. So once you know this relationship, itong mga relationship na to, madali na ma-analyze yung, madali na ma-analyze yung T-beams. Okay? So, I think we can have an example. Okay, wait. Ano pa ang dapat? Okay, wait. Maximum still ratio. Okay? What is the maximum still ratio? Ito. Okay. You have maximum still ratio is equal to 0.75 row balance plus F. Okay? Row balance, alam na natin yung row balance. Pero yung F is equal to A is 1 BWD. Okay? And row minimum, walang pinagbago. 1.4 over Fy. Okay, now there are cases now when we try to analyze the beam, the rectangular beam. Oh no, I should say the T-beams. Ano, dahil sa yung moment is just minimal. Okay, ito yung T-beams natin. Now, in the analysis of since na yung MU natin is just minimal or maliit lang, so it happens na yung internal moment na nakikreate niya is maliit din, obviously. MU is proportional, directly proportional sa MN. Pagka malaki yung MU, malaki din yung internal moment. Pagka maliit, maliit din yung internal moment. And MN is also proportional to A. Pagka maliit yung nominal moment, maliit din yung ang compression block. So pagka maliit ang compression block, there are cases na andito lang yung A niya. Okay? So, sometimes andito yung neutral axis at saka, siyempre, andito yung reinforcement. Andito lang yung A niya. Okay? Pagka prinat ko yung internal force, ito yung T, ito yung C, yung A is andito lang. Okay. So, the case is, when A is less than the thickness of the slab, not T, okay, this is T. Pagka maliit, we are going to treat this one as rectangular beam. Treat rectangular beam. Okay? We treat rectangular beam. Ibig sabihin, wala ka ng wala ka ng C1, wala ka ng C2. Ang compression block mo, ito lang ang volume, ito lang yung area. Ito. Only this side. Okay? And in this case, what is our value of C? If you have this one, 0.85, lagi ito, 0.85 FC prime. So therefore, your FC prime, your C is equal to 0.85 FC prime. Okay? Multiply natin sa A. And then, ano yung B natin? Ito yung BW. Ito naman yung B. Okay? Multiply natin sa B. Okay? 0.85 FC prime, A times B. Okay? 0.85 FC prime, A, at saka B. Hindi BW, okay? Not BW. Ang mga analysis usually sa T-beams, analysis is when the analysis is located in the midspan, Ibig sabihin, yung midspan, ang reinforcement is, ang tension reinforcement is nasa baba. Okay? At the bottom. Halimbawa, here. This is our beam. Dito, anditong bakal, So, andito yung analysis natin lagi. Kasi andito yung bakal. Kasi pagka kung nasa support, if our analysis in the support, wala na tayong consideration sa T-beams. Bakit? Andito yung bakal. Okay? If the reinforcement is here, what will happen to the internal force? Okay? This one is our T. And then this will be our compression force. Compressive block is here. So, walang mangyayari, kasi andito lang. So, ganun pa rin. Rectangular beam pa rin ang orientation niya. Unlike here, pagka nandito yung compressive block, you're going to treat this one as T-beams. Okay? Kasi ito yung magiging area concentration of the compression block. Okay? So, hatiin mo siya ng una dito, and then the other one is here. Okay? C1, and then you have here C2. Okay? So, yun lang. Okay? So, let us try example. Okay. The floor system shown. The floor system shown has a slab thickness of 75 millimeter. So as yun, you have 75. And then spacing of beams is you have your 1.8. And the span of the beam, L, is equal to 5.4 meter. The beam is subjected to a dead load of 270, and then live load moment is 460 kilonewton meter. FC prime is 20.7 megapascal, and then Fy is 246 megapascal. Number one, what's the question for number one? What is the depth of the compression stress block? So ang tinatanong is, what is A? So to do that, dapat makakompute mo yung C1, what is your C1, what is C2, ano, para makompute yung A. But first, let us first decide what is the value of your width of the flange. Okay? Okay. So what is B? B first. Okay. Number one, or letter A, it should be, it could be B is equal to 1/4 of span. Okay. What is the 1/4 of span? 1/4. And the problem is given, span is 5,400. Okay. Which is equal to 1,350 millimeters. Number two, B could be 16T plus B prime or BW. 16, ano yung thickness? Given to be 75, ano? Given naman sa problem. Plus, B prime is 375. Okay? So this one is equal to 1575. 1575. And then you have the next condition. You have the spacing of the beam, which is 1,800. Okay, so what are we going to use? Of course, very obvious, ano? Ito yung pinakamalit. Okay, so we'll have here, okay, ito yung beam natin. Okay, wait, let's draw. You have here, okay, this is 75, and our calculation says na kung ito, 1,350. Okay, this one, okay, this is 375. Okay, if this one is 375, 1,350 minus 375, then divide it by 2, will give you 487.5. Pa-check nyo na lang, ano? This one is 487.5. Ito rin is 487.5. Okay, so we have here our reinforcement. Okay, so we'll see. Draw muna natin yung okay. So first, we can assume here, ano? We can assume. We consider first this side. Okay. You have here C1 or T1, and then this one, we consider first. You have here C1. And then here, ito naman, para naman sa T2. You can add. This one is T2, and then this one is C2. Okay? Because the question is to compute for A. Ano? Ano daw yung A? For us to compute, okay, we have to compute first MU. Okay? What is MU? MU is equal to 1.4 moment dead load plus 1.7 moment live load. Given naman sa problem, yung dead load, okay, equal to 270. And then you have live load 1.7 times 460. So therefore, MU is calculated to be 1160. 1160 kilonewton meter. For us to compute for A, we know that MU is equal to phi M1 plus phi M2. Kasi dito sa M2, makukompute yung A. Okay? If we could calculate M1 and then we have MU, then we can calculate M2. Okay? So first we calculate M1. Okay? What is M1? From here, ano yung M1? So here, M1 is phi. Ano gagamitin natin dito? We can use A is T1. So mating A is 1 Fy times D minus T over 2. Okay? Take note, ano yung mga values dito na hindi pa natin na 1. A is 1. Okay? What is A is 1? First, what is C1? Here, this C1 is 0.85 FC prime, and then you have thickness 75, and then you have, for this one, yung total ng 487.5. Okay, so you have a 0.85 FC prime, tapos yung thickness na 75, and then ito, ito, isa, and then dalawa. Ibig sabihin, twice of 487.5 will give us C1. So C1 is 12866. 12866 point, tama, 1286634 pala. Okay, Newton. Now, if we can equate this one, okay, to, we have C1 is equal to T1, which is equal to AS1 over Fy. Actually, pwede AS1 na lang dito sa M1, M1 is equal to C1, 1286634, that is for C1. Reduction factor pa pala na 0.9. Ito, we use, instead of this one, we can use C1, okay? What is D? Given ba yung D? Effective depth is 600. Okay. D is 600. You have your 600. Okay. Thickness over 2. 75 over 2. Therefore, we can calculate M1. Factored na to, no? M1 is equal to 651.4 times 10 to the power of 6 Newton millimeter. Take note, na-compute na natin yung MU. Ano yung MU? Ayan, 1160. So therefore, we can compute, okay, M2. Kasi M2, we are looking after M2 because M2 can give us A, or depth of the compression block. MU minus M1. MU is 1160 minus 651.4 will give us M2. Okay. What is M2? 508. 508.6. Okay. Kilonewton meter. Now, since the question is looking after A, okay, we can have now this relationship that M2 is equal to phi. We can use C, C2. What's the value of C2 here? Okay. C2 here is 0.85 FC prime A times ito. Take note, ang 2 is ito, ano? Ang multiply mo na is this side which is 375 or BW. Okay, so we can have your C2 times. Okay? The moment arm is D minus A over 2 na. A na, ano? Ito. A. Kasi this one is A over 2. So, what is C2? You have your 0.9 and then you have C2 is 0.85. FC prime is, ano ba yung FC prime? 20. Okay. Then you have A. Ano yung A? Yun ang tinatanong. Okay. BW is 375. Okay. And then you have D. D is 600 minus A over 2 or 0.5 A. Okay. Equated to M2 ano is equal to, na-calculate natin kanina, yan, 508. 508.6 times 10 to the power of 6 na, ano? Dapat Newton millimeter na siya para consistent. Take note, this one is Newton millimeter squared. This is millimeter, millimeter. So we expect the value of A to be in millimeter. Okay? So you can come up with this quadratic equation. A squared, ano, may mga calculator naman kayo na maganda. You have A, and then you have plus 171294, 171294.32 equals to 0. So from here, we can calculate A. Okay? So therefore, A here is equal to 165.6. 6 millimeter. Second question, what is the area of steel? Okay. Second question, ano yung AS? AS should be A is 1 plus A is 2. So, meron tayong M1 kanina. Ano, na-calculate natin yung M1 kanina na, ano ba yun? We calculated M1 which is 651.4. 651.4 times 10 to the power of 6 Newton millimeter. Okay. We can equate this one para makompute yung A is 1, phi T1, ano, D minus, ano, para sa 1, to, D minus T over 2, thickness. Okay. D minus 75 or thickness over 2. So from here, you can have 0.9. T1 is AS1. And then FY. What is FY? 345.6. Then you have D. Ano yung D? Ano yung D natin? 600. So we have here 600 minus 75 over 2 is 37.5. Okay. We have this one, 651.4 times 10 to the power of 6. So therefore, we can compute here A is 1. Okay. Try and you calculate. Okay. A is 1 is, A is 1. Calculate nyo is 3723. Ready check kung tama. 3723 square millimeter. And then the same with M2. Kasi given na na-calculate na rin natin yung M2 kanina. Okay, M2 is equivalent to 508.6. 508.6 times 10 to the power of 6 Newton millimeter. Then you have also 0.9 AS2 times FY 345.6. Okay. Then you have D na 600. This time is over A over 2. A na calculate na rin natin kanina, equivalent to 165.6. Here, this is 165.6. So we can calculate here A is 2. I expect the value of 3162. Okay, 3162 square millimeters. So therefore, you have AS is equal to AS1 plus AS2. AS1 is 3723, okay, plus 3162 will give us a value 6885. 6885 square millimeter. Okay, number 3. For number 3, the question is, compute the maximum still ratio. So ito formula lang, ano? What is rho max? Rho max is just equal to 0.75 rho balance plus rho F. So you have here 0.75. Okay, ang rho balance is 0.85. Ano yun? FC prime beta, and then 600 over Fy 600 plus Fy. Okay, this is for rho balance, and then for rho F is equal to A is 1 over BD. Okay, take note na A is 1, na-compute na naman natin kanina. Ayan, 3723. B is equal to, yung B natin. Take note, this is BW, okay? It's BW. Kasi pagka B, width of the flange. Width of the flange is 1,800 yata. 1,350. So kung BW, it's 375. 375. And then D, you have 600. Okay? So yung maximum natin na still ratio, multiplying 0.75, calculate nyo na lang. Meron naman tayo itong beta, C prime, and then you can have the value equal to 0.033035. Okay? Any question? Okay, I think kung na lang muna tayo, no? Next meeting naman. Wala na ako ng boses. Okay lang?
Okay po. Okay po. Okay po.
Okay. Salamat.
Okay po, sir.
Okay po.
Okay, so next meeting na lang tayo. Continue tayo ng may mga 2-3 problems pa tayo sa T-beams, and then we'll go to shear reinforcement. Anyway, within the tracks naman tayo, schedule. Okay, if no more questions, then we'll see you next time.
Okay po. Good night po, sir.
Okay,
po,
good
thank
night.
you.
Okay, salamat.
Thank you, sir.
Okay,
Good
bye-bye.
night.
Sir Ruben, salamat. Okay, bye-bye. End ko na, ha?